Welcome to the second session of week 1 of the lecture series on blockchain technology. The goal of this series of lectures is to explain in growing detail and depth the technologies behind blockchain. This session is about a collection of chain of blocks that is called the blockchain. In this video we will look at the construct called the blockchain. First we will set a background by looking at linked lists and files. Next we will look at the collection of blocks and how these are connected by hash pointers. The immutable property of the blockchain is one of its most wanted properties. We will look at how this works. Next we briefly discuss where the blockchain is stored and how it is built and by whom. If you've done some programming or have followed computer science courses, you have seen the linked list. This is a list of entities containing data. Part of the data in the so-called list item is a pointer to another list item. By using this pointer, which is essentially the address in memory of the list item pointed to, we can construct a list of these items. This is called a linked list. It has some very nice properties like adding items or nodes at the front or the back. So let's add a node at the end of this list. Just as easy as adding an item and adding a pointer to that item. Inserting into the list is also fairly easy. Let's say we want to add this one in between the first and second ones. Be done like so. Linked lists are used in many places, for example in the document object model behind all pages shown through web browsers. Linked lists are also used in file systems. The items in those lists are called inodes. The inodes also contain pointers to blocks on a hard drive. These blocks together form a file. Next to pointers to the next inode. An inode also has pointers to the blocks on a file, on the disk. So these are the blocks on the disk. The collection of these blocks being pointed to by these two inodes is what we can call a file in the file system. Adding, removing or changing data in the file happens in a similar way as shown before for the linked list. So in general, the property of the linked list is mutability or ability to change. As we have already seen in the previous video, the blockchain consists of a number of blocks of fixed size containing information or data. These are 3 of those blocks containing data. Next to the data, each block also has a header containing information about the block, like a sequence number and a timestamp and some other vital pieces of information. These are the headers of the blocks. most important part of the header is a pointer to the previous block in the chain. This is a hash pointer indicated by the H, meaning a hash of the previous block is also included. For Bitcoin, for example, this is a SHA-256 hash, so cryptographically secure. As we will see next, adding this hash to the pointer completely removes the easy mutability of the linked list that we saw earlier. On this slide we see a number of blocks. Let's number them. Let us assume 103 is the latest constructed block in the chain. Now suppose we change the content of block 101. This would change the content of the entire block 101, but this means the hash of that block also changes. Changing the hash of block 101 that is contained in the header of 102 changes the content of block 102. This means that the hash of that block also changes. As this is contained in the header of 103, we also need to change the hash there. Now we have changed the header of 103, but everyone, however, knows the top hash pointer. This one. This means this change is visible to everyone, as this is now no longer a valid hash pointer. As long as we create a rule that the top hash pointer cannot change within certain boundaries, we also set the chain of blocks pointed to by that hash pointer to be unchangeable or immutable. So now we know what the blockchain looks like. The next question is, where is it stored? Essentially all the nodes in the network have an entire chain. On an initial connection to the network, the node downloads all the blocks from the nodes it is connected to. On this first load, the node should also check the validity of the entire chain. This means starting from the very first or genesis block, check the rules for a block and whether all the hash pointers are correct. Storing the blocks on all nodes makes this highly redundant. Once a blockchain becomes big, however, this might become an unsustainable situation. Since there is no central repository of the chain, there is no central control over the chain. So who builds this blockchain or the blocks, and how? Well, nodes in the network build the next block. They each built their own proposal for the next block. These do not need to be identical. Most often they are not. The first thing they include is the pointer to and the hash of the current latest block in the chain. This is needed to continue the chain in the right way. Every node incorporates the information, data or transactions it has. This is not the same for all nodes, as we shall see in a later video. More detail on how the next block is selected will be shared in the video on the consensus model. This concludes the second video in the lecture series. I hope you enjoyed it. The next video will go into the network we use to build and house the blockchain. For questions or suggestions, please contact me on the email address shown. You can also use this email address to suggest topics for future videos. Thank you.